Question 3. A dealer in Las Vegas selects 10 cards from a standard deck of 52 cards. Let Y be the number of diamonds in the 10 cards selected. Which of the following best describes this setting? All right, so without reading the full answer choices, I can see that 3 of them mention a binomial distribution and 2 of them mention a geometric distribution. Okay. Now, because the number of trials is fixed, we're only selecting 10 cards, no more, no less, right? This is going to be a binomial distribution. So I can already eliminate D and E. Okay. Now, a geometric distribution, if you're curious, would be something like, oh, the dealer is going to start selecting cards and then they'll stop selecting cards once they get their first diamond. Okay. But that's not how the problem is set up. Okay. All right, so since we've narrowed it down to binomial, let's check the 4 conditions. Okay. So B stands for binary. So we need to check, can the outcomes be classified as successes and failures? Okay. A success would be any card that's a diamond, and a failure would be any card that's a non-diamond. Okay. All right, so the setting here meets that first condition. I stands for independent trials, okay? Meaning the outcome of the first card should not affect the outcome of the next card or the card after or the card after that. Okay. Now, we've got to be careful here because the problem doesn't specify whether the dealer is replacing the cards back in the deck or not replacing the cards. Okay. We know that if the cards are not replaced, then the probabilities change on the next card, right? Like if I remove a heart, if the first card I pull out is a heart, now it should be more difficult for the next card to be a heart because now there's fewer hearts in the deck. But if we assume that the cards get replaced, then we're basically resetting the deck every time we draw a card, and that would make the trials independent. Okay. So we're going to write this is true if the cards are replaced. Okay. However, it would be false, or the condition would not be met if the cards were not replaced. Okay. All right. The N stands for number of trials being fixed, which we know that's true. The dealer's only drawing 10 cards, which is the number of trials. S stands for the same probability of success. Okay. So if we are to assume the cards get replaced, then the probability of getting a diamond would be 1 in 4. Right? There's only 4 suits in a deck of cards, diamonds, hearts, clubs, and spades, and they are equally likely. So you have a 1 in 4 chance of getting diamonds. Okay. All right, so all of this is true as long as the cards are replaced. Okay. So A says Y has a binomial distribution with n equals 10 observations and probability of success 0.25. Okay, yeah, that matches what we have here. N equals 10. 1/4 is the same as 0.25. Okay. All right, B says Y has a binomial distribution with n equals 10 observations and probability of success, P equals 0.25, provided the deck is well shuffled. Okay, that's important, right? That ensures that each card is random, right? That there aren't any patterns or associations in the outcomes of the cards. C, Y has a binomial distribution with n equals 10 observations and probability of success, P equals 0.25, provided that after selecting a card, it is replaced in the deck and the deck is shuffled well before the next card is selected. Okay, replacement, we mentioned how that was important for the trials to be independent. Shuffling the cards, I guess that would be important to make sure that you have the same probability of getting a diamond on every card. All right, so A, B, and C are all similar, but C is very specific, and it mentions all the things that we need, replacement and randomness.